Here we go. Okay. Let's lock it in. All right. So today we are talking about volume, right? So volume, our surface area, like I just talked about, was we're wrapping our Christmas present, right? Our volume is our space on the inside of our solid, right? If this were a fish tank, the question would be, how much water could I put in the fish tank, right? That's our volume question. Now, when I said I would give you an edited version of the formulas on the test, this is what I'm talking about. I'm going to give you something that looks like that. Oh, yeah, you can. I just whited out I whited this out right here. Watch. So, see, watch this. Here we go. See that? See what I did? Okay, watch. Okay. What I'm going to do is I'm going to give you an edited version that's going to look like that. Yes. So I will give you something that looks like that, and you're going to have to know, what do I use that for? Okay?
You're not going to tell us like what shape it's for?
No. That's what you need to make the connection on. So you'll need to know that when we're multiplying the length, the width, and the height together, that's our volume of a rectangular prism. Okay? Now, this is the easiest one, obviously, and I know you guys have done these before. So just showing your work for this is really straightforward. You're just going to do volume, and then you're going to give me 3 open parentheses. I'd tell you to pause and write the numbers in, but you know what? There's only 3 numbers. Let's just write them in, right? I mean, this is as easy as it gets right here. Okay? No, and the order doesn't matter because, you know, when we're multiplying, we can mix it all around. Commutative property, right? Okay, so then just multiply those up. Okay? Jason, don't blow ahead because we're not going to do every problem, okay? Okay, just stay with us. All right, volume is equal to 3,672 centimeters cubed. All right, so let's just kind of make sure we're on the same wavelength here, right? When we are looking for length, which you might be asked to find, what is the height? What is the radius? What is the width of the box? Okay, when we're looking for length, that's a one-dimensional measurement. I want you to think of that as just centimeters to the first power. I don't want you to write the first power, but I want you to think of it that way. When we are finding area, whether that is area of a two-dimensional shape or surface area, this is our squared measurement. Okay, and when we're finding volume, this is our cubed measurement. And this is one of the most common mistakes, even amongst honor students, because you guys go really fast, and so you skip right over the units, or you miss putting the correct exponent on your unit. Don't lose easy points. This would be a great thing to double check before you turn your test in on Monday. Go through it and be like, hey, did I get all my units? And am I putting cubes where I'm supposed to and squares where I'm supposed to? And maybe, you know, just having the centimeters by itself if I'm supposed to, okay? All right, that's easy, right? We don't need to do another one of those, do we? Okay, good. Moving on. All right, number 4. Okay, now, as we talk about all other prisms, okay, the formula is very easy. All we have to do is find the capital B area of our base, whatever shape that is, and then we multiply it by the height of the prism, right? Okay, so let's highlight our bases on number 4. Let's highlight and color in our bases on number 4. You should have put those right there. All right, now, we need to find the capital B area of one of our bases. What type of shape is this? What is this solid called? Triangular prism, right? Okay. Now, we need to find the area of one of the flat two-dimensional triangles. What's the area for the formula for the area of a triangle? 1/2 base times height. Very good. All right. Okay, so then you need 2 measurements here. Now, this is the base that meets another measurement at 90 degrees on the flat two-dimensional surface. Write in your numbers. Okay. So you should have put 12 and 7.3. Right, because you can see the 90-degree marker here. So we're using these 2 measurements flat on one of the bases. Okay, these are the 2 measurements on the flat plane that meet at 90 degrees. Okay, now once we have that, what do you get for the area of the triangle?
43.8.
Yeah, and we won't put the units in until we get to the answers. So All right. Let's focus. There we go. All right. So 43.8 is the area of our triangular plane. And then we're multiplying that by, what's the height of the solid? 5, right? Again, that's the distance that separates the two planes, right? Okay. What do you got?
219.
Very good. 219. Or you could say cubic feet. That's another way of saying it. Squared feet, cubic feet, or feet cubed. Either one is fine. Okay, that was easy, right? Yeah? Okay, let's skip number 5 then. All right, highlight your bases on number 6. Highlight your bases on number 6. Come up with a name for that shape too. Okay, correct highlighting of your bases. You should have put those two there, right?
Right. Get into it.
Now listen. Important that you can name these correctly, but it's also helpful because if you say, oh, that's a trapezoidal prism, as soon as you give it that first name trapezoidal, you know you need to be highlighting trapezoid bases, right? So that helps you double check yourself. All right, we need the capital B area of one of our two-dimensional flat trapezoidal planes. So why don't you write down what you think the formula for finding the area of one of these planes is. Go ahead and write it down on your paper now. If you got the right numbers in the right place for your area of a trapezoid. Right, so it's 1/2 times the height, and then the two bases are the parallel sides. So this is a parallel side, and then there's our height and another parallel side, meeting at 90 degrees. What's the area of our trapezoidal plane? 447.5. All right, good. Right, and then volume is really easy. Again, once you know the area of one of the bases, then you just multiply by the height of the solid, which is what in this case? Yes, that is right, 25. The distance that separates the two planes that are the bases.
I got it right.
Yeah? Everybody good? Okay. How are we doing so far? Pretty easy? Pretty good, pretty good, pretty easy, pretty quick? All right. All right, let's do number 7 together. Let's do number 7 together. Let's start by highlighting our bases.
I'm so good at that.
That's good. All right, highlighting your bases, you should have come up with those. What kind of a solid is this? It is a, what kind of solid is it? Triangular prism. Okay, now we need to find the area of one of our plane bases, right? Capital B area. So we got earlier, it's 1/2 times base times height, which are two measurements that meet at 90 degrees. What? What do you mean? Why would we use the Pythagorean theorem? Oh, yeah, because we know this one, but we don't know this one, and that's where it meets at 90 degrees. It's not going away. It's going to be here all year. Hey, why don't you give yourself a little squiggle here, and then any extra, I don't know, like, you know, Pythagorean-ish type work can go over here on the side. Okay. I'll tell you what. I'll let you just finish the problem. All right? Let's see what you can do. Ready? Go. I'll give you some checkpoints. I'll give you a checkpoint. I'll give you a Pythagorean checkpoint, all right? And then we'll finish it up. Let's see what you can get. Okay, let's see if you're on the right track. You should have been going here.
Oh,
yeah, I did that.
Okay, good.
I put it as... Never mind.
BX, whatever. Doesn't matter. Whatever you want to call it.
I did it as... I put it as a squared plus 22. Is that okay?
You put it as what? Did you come up with 7,161 cubic kilometers?
Bro, why are you
Okay, good. All right. What do we got going on here for a shape in number 8? What is number 8? Trapezoidal prism. Let's highlight our bases. Okay, highlighting your bases should have looked like that right there.
Friends.
The height is 39.4.
All right, so our trapezoid formula, right, is 1/2 times the height of the trapezoid, and then the two base numbers, right? So what are the? Let's get the base numbers. Do we know base numbers? What are the base numbers?
25. 39.
Yeah, 25, right? Because that's one, and then this one here, that's the other parallel side. And that's 39.4. All right, so 25 and 39.4. Do we know our height number? That's the meeting the bases at 90 degrees.
No. You have to do the Pythagorean theorem?
I don't know. We do? How would we do that? Just do it? How would you just do it?
Wait, like you would fill in, you'd have to find the C squared. Wait, no.
Well, where's the right triangle?
It should be the bottom. Wait, shoot, no. Well, because
Right, we're looking for this, right? All right, reading, you want to tell us, where's the right triangle?
The height of the triangle from subtracting 25 from 39.4.
We have to do what?
Subtracting 25 from 39.4.
Did you guys catch that, what he said? You got it. You got to find the height by subtracting 25 from 39.4.
25
Like the,
Oh, I get it.
wait.
You get it? You want to explain it?
I don't get it. Can you explain that, please?
Because
Pedro's going to explain it.
wait, to find the height between the two bases, isn't it already 35?
No.
That's the height of the solid.
We're looking for the height of just the base.
Well, what we need is we need a right triangle somewhere, right? Like, do we want like that or that? This right triangle here?
Yeah.
Okay, all right. So we know one side, right?
Yeah.
But we don't know the other side, right? We don't know this side either. We got to know 2 of the 3 sides to get a right triangle.
Okay.
So that one doesn't work for us.
What you can do though is
What can we do?
Tell us, Pedro. I don't know.
No? No. Ruben, you want to give it a shot?
Yeah, 39.4 and subtracted by 25, so you can get.
Wait, that's the same thing that Reedon said.
Oh my God.
Wait, what? Wait a minute. These guys are on the same page? Now you guys are on the same page? Why would you do that, though?
So you can get the side A, and you can do
Where's the right triangle? Where's the side A you're talking about?
right here. You see right there on top.
Where?
Right. I don't know how to explain it. It's like up on the top of the
Like, are you talking about like this measurement here?
the one like line below it. Like at that point, you just go right.
then you go to things.
So you're talking about like, what, like that?
Yeah.
Ow!
Oh.
Wait a minute. Hang on. So you're saying we can draw a line across like that? I could probably answer that question for you, but I'm not going to.
I get it. So you have to like cut it to make it square.
Okay, well we have a square, yeah, but how does that help us with Pythagorean theorem?
You have to subtract the.
I don't know.
That's what it is already. Like the X.
14.4
squared.
Wait a minute. Let me write that down. Hold on. Say that again, Ruben. What'd you say?
14.4 squared.
Hold on, listen. 14.4 squared
Plus B squared
plus B squared
equals 30.6 squared.
equals 30.6 squared?
Yeah.
And where's that 14.4 come from?
39.4 minus 25.
This right here comes from 39.4 minus 25. Yeah.
Is that right?
Yeah. Question.
Because you make, wait, I was to Wait.
Yeah.
It's because you make the squares on both sides of 25, so then the extra is like just like hard point.
Sure, that would be like right. So if we were going up 25 here and we stopped, right? If we went up 25 here, we'd stop. We'd be right across from that point, right? But we got to keep going a little bit more, right? Well, that's why we do the 39.4 minus 25. And then we use that to find 14.4. This is I don't know. And this is 30.6 because it's the same from this side.
I understand.
Okay, everybody got it now? Nice job, you guys. Thank you for being patient. That was good that you saw that.
So now I have both sides.
So this whole thing is 39.4. Okay? I'm going to break it into two parts. Watch. From here to here is 25. And from here to here is 14.4, which totals this.
No, it's never there.
Oh, there it is. Okay. All right. There it is. Okay. Good. All right. Okay. Finish it up. Finish it up.
No. Sorry. I'm on it.
I got 30,429 too. Woohoo! Yay, I got it right. Okay. So, okay, now, all right. Let's focus for a second. Let me have you right here. 3, 2, 1. Right here. Okay. Now, we did a couple of questions that had Pythagorean theorem buried inside of it, right? So, be on the lookout for Pythagorean theorem questions looking for right triangles. Again, it has to be right triangles, and you need to know 2 of the 3 sides. That's what the Pythagorean theorem tool does for us. So, be watchful for those, okay? Just make sure that you're aware of them, all right? Okay. Cylinders. These are easy. These are just prisms with circular bases, right? So, look. Our volume for prisms. Focus. Our volume for prisms was base, area of the base, capital B, times height. Well, then it would make sense that this is pi r squared times height because that's just the area of our circular base, right? So that's why it's written like that. So if we were to come over here and do this one, this is like one of the first ones we did. It's really simple. We would go volume is equal to pi radius squared times our height. What's our radius in this one?
18.
Good. And what's our height? 15, right? And so then for this one, we would go volume is equal to multiply. Remember, square first, then multiply by the 15, right? PEMDAS, do your exponents before your multiplication. Okay, what do you get?
4,865 inches.
Now, I think we talked about this the other day, but let me just emphasize this. I saw this quite a bit on the test. That's not right, okay? Because it's not the pi being squared, it's the units that are being squared. So you want to make sure that you're writing that down.
Would you not
Oh, sorry, yeah, cube. I was thinking about the other day. Yes, you're right. Cube. Thank you. Okay. All right, now we're gonna skip 10. 10's pretty easy.
These are the weird ones.
Here we go. No, we're not gonna do 10. 10's too easy. We're gonna do 11 though.
No, because I think
Yes.
I think we're being great.
No. Okay, now I do need to point something out to you. About number 11. If you look, and it may be really kind of hard to see on your paper, but you could write it in. If you look right there.
Oh my, is there
Okay, so sort of keep that in mind. Okay, so we are looking for a cylinder that has a 2-centimeter diameter, is drilled through a triangular prism on the left. Find the volume of the prism. Okay, go ahead. See what you can do. The circle part, the cylinder part, has been drilled out of the triangular prism. It's been removed from the triangular prism. Okay, good. I'm glad.
No, I understand. This is like
How about we just see what's right? The right answer is 131.02 cubic centimeters. Okay. Those of you who didn't get it, figure out where you did wrong. What did you do wrong? Yeah, yeah. Because in that case, because you can't subtract that without that. Yeah, without that decimal approximation.
That's what I did. What? Why would 5 be the height? That's the right.
Because why would what?
It's 5 the height. The right.
Yeah. So the right angle is, so it's 5 and 5.
Okay.
So that's the base and the height. Yeah. 2 o'clock. 1:55. All right, you ready? This one's a good one. This one's a tough one.
It's a tough.
This one's a challenging one.
Why am I writing about principles?
This one's a little challenging. Okay. I'm gonna give you a hint on this one, all right? Here's my hint for you. So here you see the diagram of Eric's pool. He's gonna fill his pool to a depth of 4 feet. Okay. With a garden hose that fills at a rate of 80 cubic feet per 1 hour. Okay? How many hours will it take him to fill the pool? To 4 feet. Yeah.
So instead of solving it at 4.5, will I just like solve it 4 feet?
Sure, because it would only be filled to 4 feet. All right, I'm going to give you a hint. So here's my hint for you. If it's being filled at 80 cubic feet for every 1 hour, right? And we want to know how many hours would it take to fill the pool. Then we just want to know what is the full cubic feet, right? Whatever that number is there. Then we could use our proportion to figure out our number of hours.
I'm just but if you're trying to find instead of 4.5, you just use 4 to 4.5.
Well, sure, because he's only filling it to 4 feet, not 4.5 feet.
I don't like dividing my feet.
Okay, good luck. Did you come up with 28.63?
Yes!
Yes?
Yes!
Yay!
We just say like around 29 hours exactly.
No, I mean, unless it says, specifically says rounded, then just go with what the exact answer is. Yeah.
I just did it.
I mean, really, Natalia, if you had gotten all this work on your paper here and then you had said about 29 hours or about 28 and a half hours, that'd be okay too. I'm not going to mark that down because of all of the work that you've shown here. Like you've shown that you understand that you're, doing this cross proportional multiplication. So, all right. Good? Makes sense? Everybody cool? Not too bad, right? Okay, I'm going to leave it up there. I'm going to pass out homework for this lesson. We're not doing every problem, so get ready to circle.
Oh, I'm so ready.
Huh? It's a possibility. They're fair games. We've covered them in class. So it's definitely fair game.
I'm gonna like that.
Why did you divide it by 80? I got everything.
So the relationship is over on the right. So the idea is that it's filling at 80
Oh my god!
What we're looking for is how many hours are you full, right? So we're trying to make volume is full. I'm going to put that 2290.22 where that little box is full is, right? Now I've got 3 of the 4 numbers in my proportion. So now I'm going to cross multiply. 2290.22 times 1. Just that equation.
You're doing it
times x.
Now.
The other side.
She deserves it.
We're taking the full volume and we're dividing it by 80 feet for every hour. That'll be
Someone get that.
all right, ready here. We're circling.
Oh, wait,
Let's go. Sing it.
Okay, homework for volumes of prisms and cylinders. Ready? You're doing 1, 3, 4, 1, 3, 4, 8, 9, 14. 1, 3, 4, 8, 9, 14.
That's it?
Well, that's because we got a whole nother lesson to do.
What?
Yeah!
That's not
We have a whole nother lesson to do. I told you we had 2 to do today. Pyramids.
It's Friday!
All weekend.
That's how teachers think. Don't you know that? Like on a 3-day weekend, you have even longer to do homework.
Hey man, if I got to go over this weekend, you got to go over this
Unless you don't give me school.
Stop.
Okay. All right, here we go. Now, continuing on.
Are we doing all of these?
No. All right. Continuing on. We also have to get our volume of our pyramids and our cones. Now, I don't have a lot of time to explain why. So in this case, there's plenty of videos out there if you want to know why it's a third. But basically, you can take 3 pyramids, disassemble them, and you can put them into a prism. So you take any prism and break it into 3 pyramids. So if you want the volume of a pyramid, all you got to do is find the base. And instead of going all the way up like a prism, we're just going to take a third of the volume of the prism. That's what it ends up being. It's a third of the volume of the prism in that case. So with that being said, it makes it fairly easy to do these questions. So we got to start with the capital B area of our base. This is rectangular. So it's just going to be 10 times 11. Then once we have that, which is what? 110. Then we can start our volume. So I'm going to tell you, I think it's probably easier just to do it this way. But you do it however you want, but I would recommend doing your area of your base times what's the height of this? 15 inches. Okay, so the height, this height, right here, just so that we're clear, is the line that goes from the center of the base up to the point of the pyramid. Okay? It's not the slant height. The slant height is going to come into play, as you'll see. Okay? All right. And then what I would do is I would do that math, and then I would divide by 3.
I understand.
That would be the easiest way to do it. Same thing. Multiply by 1/3, divide by 3, same thing. Yeah. It can. Yes, it's possible. Yeah. So when we do, especially since we're dividing by 3, right, in that case, so what do you get when you do this math problem?
586.
Right. And so for these, we'll put right here, we're going to round to hundreds for these, okay?
Okay, so you don't want to put the bar over.
Nah, we'll just round these, yeah. 100. There we go. So 586.67 cubic inches. Yes, question.
I mean, make it a fraction that's 2/3.
No, I would prefer you do the division out. Yeah. It'll match the answers more when I show them to you. All right, that's fairly easy, right? So it's just plugging in the numbers. Is everybody okay? No? It's area of the base, and then it's a third of that area. Okay. Let's do number 3. Okay.
Oh my god.
So let me give you a hint.
You have to do the Pythagorean theorem.
How?
You do 25, and then you have to find the radius, which is 7.
Radius? We don't have a circle.
The middle point.
The middle, like the middle of the base, like right here.
It's 7 because all points are like equally in it. So 7.
So you're saying this right here is 7? because it's 7 to the other side.
And then you have to do 25, so that's already the hypotenuse.
Okay.
You have to find B.
So then we're coming down this way like this, is what you're saying?
Yeah, we have to find that line right there.
Okay, so that's our height line?
Yeah.
Okay. So what's the Pythagorean theorem problem we use, Pedro?
7 squared plus B squared equals 25 squared.
Good. 7 squared plus B squared equals 25 squared. Okay? So find your Pythagorean theorem, and then once you know your height number, then you should be able to effectively calculate your volume. Go ahead and finish that problem up. Let's take a look. You should have been able to come up with 1,568 feet cubed.
She's not used to getting it right.
Okay.
I got 1968.
Okay. All right, a couple things I want to point out to you. Watch up here.
I'm watching.
If you don't see it, this is the 90-degree marker of the height line coming down. This is the 90-degree marker of this line on the base of the pyramid. Okay? Enough said there. Number 5, you got a couple of 90-degree markers again. This is the one of the height line coming down. This is where the 2 back corners of the triangular pyramid face meets. I'm just pointing some things out, okay? All right, we're not going to do these. All right, we're going to skip 6. Okay, let's go to number 7. Okay? So, again, this is just 1/3 of the volume of a cylinder. So all you got to do is, if you know volume of a prism and volume of a cylinder, then, you know, it's 1/3 of that. That's all you're doing. So you're finding that. And again, you've got your pi r squared, you've got your height line in the middle, you've got your lateral slant line. So in this case, pretty straightforward. Our volume. Wait, we need the area of our base. What's that? Yeah, number 7. Yeah. Yeah, we'll just do the whole thing in one step, since the formula's in one step. All right, volume is equal to 1/3, and then it's going to be pi, and then it's going to be radius squared, and then it's going to be height. Okay, what's that? It's what? Oh, sorry, 1/3. I said it, I just forgot. Okay. All right, here we go. Okay, so we get our 9 in here, we get our 17 in here. Yeah. Volume is equal to, what do you got? 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 459 pi cubic yards. That's easy, right? We don't need to more of those, okay? Okay. Number 10. All right, cone has a volume of 1,309 centimeters cubed. If the height of the cone is 8 centimeters, find its radius. Go ahead, give it a try. See what you can do. You're moving in the right direction. You should have been heading this way. Yeah?
Not yet.
Not quite? Almost there? Should have come up with 12.5 centimeters.
I think we're right now.
Close enough.
What have you done?
That's fine. Kind of depends on where you round it that it goes to, you know. So. So this is one of the ones I was talking about where you're going to have to use that approximation in there, right? And again, this is a individual single measurement, right? So this is a length measurement we're looking for here. So just keep that in mind. Okay. All right. Yeah, I think 11 is really easy. Let's do 12. All right. So 12. Just catch what it says here. The cylinder to the left contains two congruent hollow cones. If the cylinder's height is 20 inches and its diameter is 14 inches, find the volume of the solid. Okay? So what they're saying is this cone in here is hollow, and this cone in here is hollow. And they're exactly the same, one on the top and one on the bottom. Okay, go ahead. See what you can do. Okay, you ready to take a look? We pretty close? All right, should have come up with about 653 degrees. All right. We're not doing all of them, so get ready to circle.
Thank you.
We're not doing all of them, get ready to circle.
All that is the bathroom.
Oh, put 980.
Okay, we're not doing all of them. You ready to circle?
Yes.
Okay. So, for this one, ready, here we go. You are doing 2, 3, 4, 7, 11 through 13. 11, 12, 13. 2, 3, 4, 11, 12, 13. All right, that's it. Have a great weekend. Get some practice in. Quiz on 3D on Monday. You guys got this. It's not that tough. You'll be able to do fine. You'll do fine.
It's just like the application problems
But you got that one right, so you're good.
one of them, out of like the 70.
You got more than one of them right. Come on. Yeah, you're good to go. Have a nice one. See you later. Hasta la vista.
You know.